Hello everyone! Today, we're diving into one of the most elegant and, let's be honest, mind-bending concepts in programming, recursion. At its core, recursion is a way to solve a problem where the solution depends on solving smaller, simpler versions of that same problem. In the world of code, this means a function calls itself. Now, I know what you're rethinking. Does end-to-function calling itself sound like a recipe for an infinite loop? And you'd be right, it absolutely would be, except for two critical components that make recursion work its magic. First, you have the recursive step. This is the part where the function actually calls itself, but it does so with a slightly smaller or simpler input. It's chipping away at the problem, piece by piece. Second, and this is the most important part, you have the base case. The base case is the condition that tells the function to stop calling itself. When the base case is met, the function returns a value directly without making another recursive call. If you forget the base case, you'll crash your program with a Stack Overflow error. It's the safety net that prevents infinite loops. Let's make this concrete with a classic example, calculating the factorial of a number. The factorial of a number, written as n with an exclamation mark, is the product of all positive integers up to that number. So, the factorial of 4 is 4 times 3 times 2 times 1, which equals 24. Mathematically, you can define a factorial recursively. The factorial of n is n multiplied by the factorial of n1, and the factorial of 0 is just 1. This definition is a perfect fit for a recursive function. Let's translate this into some Python code. We'll define a function called factorial that takes a number n. Inside, we first check for our base case. If n is equal to 0, we simply return 1. This stops the recursion. Otherwise, we move to our recursive step. We return n multiplied by the result of calling the factorial function with un1. So, what happens when we call factorial 4? Let's trace it. The function sees that 4 is not 0, so it returns 4 times factorial 3. Now, the factorial 3 call returns 3 times factorial 2. This continues down the line. Factorial 2 returns 2 times factorial 1, and factorial 1 returns 1 times factorial 0. Finally, we hit our base case. The result of factorial 0, which is 1, is passed back to the factorial 1 call, which calculates 1 times 1, returning 1. That result is passed to factorial 2, which calculates 2 times 1, returning 2, that gets passed to factorial 3, which calculates 3 times 2, returning 6. And finally, that 6 is passed all the way back to our original factorial for call, which calculates for times 6, giving us our final answer of 24. Recursion is incredibly powerful and elegant. It's perfect for problems that can be naturally broken down into smaller sub-problems, like navigating a file system, traversing tree data structures, or even generating the Fibonacci sequence. It can make your code shorter and much more readable, but only if you always remember that crucial base case. Thanks so much for watching. Now go out there and practice writing some recursive functions. Don't forget to like and subscribe for more coding content. See you in the next one.